Okay, hope now things are okay, no? You can see me and you can hear me well. What we were discussing about the Newton's second law. So think there is an object. What is? Let's say there is a particle with a kilogram of 5 kilograms. I need to move this particle with an acceleration of 3 meters per square second. So what is the acceleration that I have to apply on this? That force we can count by F times mass into acceleration. Now what is happening? 5 kilograms into 3 meters per square second. So when we get 15 kilogram meters per square second. So this unit we can consider as Newton. So it is equal to how much? 15 newtons. Okay. So now what is happening? Now we got a equation for the motion. That means actually equation combined with force and motion. Okay. So there is A, the acceleration. Now what happens? Already we used to calculate many things using this acceleration, using our motion equations. What were our motion equations? V equals u plus at. What else? V squared equals u squared plus 2as. Using these two equations, we could create another 5 equations, no? Sorry, another 3 equations. So S equals ut plus half at squared, or S equals vt minus half at squared, or what else? That's it, no? And we can S equals u plus v divided by 2 times t. I hope yes, this was the another one. So using these equations, now what happens? Now we can combine these motion equations with these forces. Why? We can use this acceleration to go move into the other factors also. So now the thing's going to be, we can go for complex scenarios and calculate many things. Okay. Let's look for some example. Just look at the example 6. What are they asking? Find the magnitudes of the unknown forces x and y. Okay. And also I was talking to you about the weight. What is weight actually? What is weight? This is the earth. What is this? This is the earth. Think this is an object. So what is happening? There is a force from acting by the earth. There is a force on this object due to earth. Okay. So this force we known as weight. So we can actually get that weight by how much? The mass into gravitational acceleration. Mass into gravitational acceleration. How much is it? It will be equal to weight. Okay. Later in this lesson, we will go to the talk about the Newton's third law. There we will discuss some fascinating facts about this force which happens due to Earth's gravity. Okay. Just for the moment, take that. We can take the weight force by multiplying the gravitational acceleration. We usually denote that in G with the mass of that object, mg. Okay. Okay. So what is in the, yeah, we have to find the unknown forces. Let's think about this one. 2 kilograms and how much? 2g downwards, y upwards. And what else? X horizontally and 4 newtons other way. And they say, what else they are saying? This object is moving with an acceleration of 2 meters per square second in this direction. Now we have to find x and y. How can we find this x and y? We learned how to resolve the forces. What can we do here? We can horizontally resolve and vertically resolve forces. I'm going to first vertically resolve the forces. If I vertically resolve the forces, what is going to happen? Sorry, yeah, vertically. This y and 2g. Is this object moving on that direction? No. Acceleration on that direction is 0 because it is said this object is moving on this direction only. So for when we are resolving forces vertically, we can write y, this y force acts on upward, and the weight, usually 2g, it is acting downwards. No? So minus 2g should be equal to how much? Actually, since there is no net force on this one, we can write 0, or you can apply that F equals ma equation also here. What is happening? This mass is 2 kilograms, but the acceleration is 0 on this direction. So we can, that becomes 2 times 0, which is again 0. So y equals how much? Y should be equal to 2g, because this is 0, 2g comes to the other side. So y should be equal to 2 times g. You can calculate by substituting y equals how much? 9.8. For y, usually for g we substitute how much? 9.8 meters per square second. Okay, this is the value we usually using for g. How much? This will give us 6, 18 and 19. 19.6 newtons. Y is equal to 19.6 newtons. And how much for in this horizontal direction if we resolve? When we resolve in this direction, we can have x here, and this 4 Newton force acts on the other side. So we have to put minus 4. And what is the acceleration on this side? It is 2. So when we apply F equals ma, so in this side, we have to write all the forces acting. And this side, mass times the acceleration. Mass is 2, acceleration is also 2. So x minus 4 should be equal to 4, which gives us how much? X is equal to 8 Newton. It's a very simple scenario we have to apply, but along the way we can do multiple things. Now, combined to this question, I'm going to give you some more things to calculate. Okay, I would say this object starts at t equals 0. These forces acting upon this object starts from rest. Okay, this object starts from rest. What my question is, how long will it take? How much of time does it take to come to a velocity of, we would say, 15 meters per second? How long will it take to come to this speed? And to travel 50 meters, what is the time does it take? Think these forces are there without any change, okay? How long will it take to travel 15 meters? And how long will it take to achieve this 15 meters per square second? Sorry, 15 meters per second. What can we do now? In this direction, we can apply these two equations, no? V equals u plus at, and what is the other one? And this is, from this one we can find the velocity. So velocity after final velocity, as I said, how much? 15. We need to have the velocity of 15. I said it is starting from 0, rest. So initial velocity is 0 here. And what is happening to this acceleration? Now it is 2 time how much? We don't know. We have to find that. I put T1. So when you have to divide both sides by 2, what are we having? T1 equals 7.5 seconds. And when you apply the equation, S equals ut plus half at squared, what can we have? We can have ut. How much is ut? Starting as velocity is 0, 0 times t plus half times 2 times t to the power 2. And the distance that I needed was 50. How long it is taking to achieve a 50-meter distance. So here what is going to happen? 50 equals t to the power 2. When you take the square root of both sides, you can have a value for t. Since t is greater than 0, we are only taking positive value of the square root. How much is? So 7.07. 7.07 seconds. It takes this much of a time to travel 50 meters. So now the possibilities become little bit bigger. That means we can match with the motion equations. So if you have some sort of a difficulty in solving these motion equation, then again you have to review the chapter 2. It's better. Okay, never mind. We will do a lot of questions along the way, so you will learn how to deal with this one. Now we start doing the exercise 4C, and I will start discussing these questions after 2-3 minutes. Okay, you can start working on these questions. Okay, what is the question number 1? Find the acceleration when a particle of mass 400 kilogram is acted by a resultant force of 120 newtons. 400 kilograms. So they are telling us the value is 400 kilograms, and we can think the resultant force is in any direction. Okay, let's see this direction, how much? 120 newtons. So they are asking what is the acceleration, no? So along this way, how much will be the acceleration? Let's calculate now. How much? This total resultant force we can write as F equals ma. When we apply to this equation, 120 should be equals to 400 times A. So when you divide both sides by 400, how much we are going to have? A should be equal to how much? 0.3, no? 0.3 meters per square second. The next one. Find the weight in newtons of a particle of 4 kilograms. The weight. They are asking us to find the weight. As I said earlier, what is the weight? It's the multiplication of mass and the gravitational acceleration. Mass is, how much are they saying? 4 kilograms. Yes, particle of 4 kilograms. So what can we do? So if we take the weight, this format, weight should be equal to mass times the gravitational acceleration. So mass is 4. 4 times 9.8. How much are we going to have? 2, 36, 36 plus 3, 39, 39.2 newtons. The third one, an object moving on a surface experiences a constant frictional force of 30 newtons, which deceleration, which 30 newton, which decelerate it at a rate of 1.2 meters per square second. Find the mass of the object. Okay, what they are saying now? There is an object, and think this is like a non-accelerating car. When you release the accelerator of a car, what is happening? It is only acted upon some frictional forces, air resistance and the resistance from the ground. So what they say, this resistance force is how much? 30 newtons. Okay, 30 newtons. And what else? And the deceleration rate is how much? 1.2 meters per square second. Again, similarly, we have to apply for F equals ma. What is going to happen when you apply in this horizontal direction? So 30 should be equals to mass times this acceleration, 1.2. So when you divide both sides by 1.2, how much? It's 300 divided by 12. Can divide both up and down by 6. We get 5 over 0.2. That means 25, no? 25 kilograms. If my answers are wrong, just tell me, okay? Or if you get different answers, and if you can't figure out the logic behind it, just ask, why did I get this answer? What is the reason? Can't we think like that? Okay, so asking like that is totally needed for better understanding. What is the question number 4? An astronaut weighs 307.35 newtons and in the moon. Count the acceleration due to gravity in the moon. This is a good question. Think in Earth and Moon, what they are saying? In Earth, this person, astronauts, weight is how much? Let's think him as a particle. 735. Oh, 735 newtons. But on the Moon, the same person, 120 newtons. And they are asking us what is the value of the gravity. What is the gravity of the Moon? Let's take that as G2, and we know the gravity of the Earth as G. So how can we make a combination between these two? We can separately apply F equals ma for this one and F equals ma for this part also. So what is the constant in both two situations? It's the same astronaut. So in our mind, we should feel that the mass of this person is not changing. How to do this one? Mass of this person is not changing. It's the same astronaut. So if this person has a mass of m, in the Moon also he has the same mass. So what can we do? We can equalize the masses and build the relationship between these two. We know now how to. What is our equation? F equals ma, but we don't know even m or m in this situation, but never mind, we can find m using this one. No, how much? If we apply for Earth, this W equals mg equation, weight should be corresponding to this equation. So what is our gravitational weight? 735 should be equals to mass times gravity of the Earth. So we can take mass equals 735 divided by G. And we can apply this mass in Moon. How much? 735. Sorry. What is the force? 120 newtons. It should be equals to mass times the gravity of Moon. I took it as G2. You can use any other symbol, okay? In the place of mass, what can I write? 735 divided by G. So 120 should be equal to 735 over G times G2. So when we make G2 as the subject, we get how much? 120 times G divided by 735. For G, you can substitute 9.8 also, okay? How much are we getting? Can somebody tell the answer or put in the chat? Then I can understand whether you are getting these concepts or not.
Which question is that?
This one, question number 4.
So I got 1.6.
How much?
I got 1.62.
I got 1.6.
1.6.
Okay, thank you. 1.6, no? I hope it will have this kind of answer. Yeah, 1.6. Oh, I am exactly getting 1.6. Is that the?
Yes, 1.6.
Okay, thank you very much. 1.6 newtons. Okay, is this an acceptable answer? Yes. Why? We have learned that the mass of the Moon is compared to Earth is very little, no? So that means the gravity of the mass should be lower than the G. If you take this is not in newtons, that's wrong. Okay, this is, you should write this in meters per square second. This is acceleration, no? Okay, and also if you got something like 10 meters per square second, then you should feel like it can't be. Why? The gravity on the Moon should be less, no? Even in the mass that people are trying to get their mass, what is the gravity? It is nearly half the gravity of the Earth. Okay, Okay. So this physical sense also should be there when you are dealing with these questions. Then easily you can get to know whether what you are doing is correct or not. Okay, let's move on to question number 5. Question number 5, part A. There is an object with how much of kilo? What is the weight? Not the weight. Mass is 2 kilograms. And it is accelerating upward with a speed of 3 meters per square second. There is an unknown force P acting upward, and they have given us the weight 2g. Actually, even though it is not written in 2g, you should be able to configure that because the mass is given. So you should mark the weight of this object downwards, vertically downward. So now if we resolve these forces upward, 2g, sorry, what is the upward force? P. So downward forces become negative. So P minus 2g should be equals to mass times the acceleration. F equals ma, no? Now what is happening? Mass is 2 and the acceleration is 3. Now what happens? P equals 2g plus 6. How much is g? You can apply 9.8. So it is going to be 19.6 plus 6. So you are having 25.6 newtons. That will be the answer. 4 kilograms, 10 P2. This is the part B. 4 kilogram object, P upward, 10 newtons downwards, and there is 4g also, no? And the downward acceleration 2 meters per square second is that. Yes. Now when we apply this equation to this mass, what is happening? We can apply this vertically downwards, no? What are the forces acting on this one? 4g is acting downward. What else? This 10 newtons applying here. That is also downward. So we can write plus 10. And this P, force P, it is acting upward. So we have to write minus P. And what else here? Mass. Now the forces are, we have done with the forces. So force F, when we are applying F equals ma, now forces are all these forces in this side. They are finished. Mass is how much? Mass should be equal to 4. It is given, no? And the acceleration downward, vertical downwards, how much? 2. You can even resolve this upwards. So you will have the same value, same equation, okay? For the P. It doesn't matter whether you are applying it vertically upward or vertically downward. So you get here can apply 9.8 plus 10 minus P equals 8. So when you make P as the subject, 18 plus 4 times 9.8. How much is the answer? $57.2 newtons, no? 57.2 newtons. Is it understandable to you all? Do you guys any questions?
No questions.
Okay, thank you. Tinuka, are these understandable?
Yes, sir.
Okay. Will you come tomorrow? Okay, because all the others we met last day. In each scenario, the forces acting on the body. Let's look at the question number 6. In each scenario, the forces acting on the body cause it to accelerate as shown. Mass of the body is m. Mass is m, the vertical force downward is mg, upward there is a force of 10 newtons, and they say this is moving with a acceleration of 5 meters per square second, and asking us to find the mass.
Which one is this 57.2?
Sorry?
This answer on the
If-
board?
Question number 5, part B.
I got 41.24.
41.2. Where we have gone wrong. So vertically downwards 4 times 8, that is okay. 4g minus plus 10 minus p. Yep. Okay. Is it the first row is correct? This row, the substitution for F equals ma. So downwards forces. What are all the forces? 4g here, 10 here, and p. So 4g and 10. And p is
I
up.
didn't use that method.
So which method you followed?
It says that the downward acceleration is, we know that I found the difference of acceleration. So by doing that, I found the acceleration acceleration of p.
Oh,
Downward acceleration is 10 divided by 4 and plus 9.8 ton. So
why?
total
Wait.
downward
How you got the difference of acceleration? That means
it says we
yes.
know g.
We know what?
We know g,
Yeah.
and we know the mass. So we can find the acceleration of 10 newton.
No. You can't do that. What is this 2 meters per square second?
That's resultant acceleration, right?
Yes. That is the resultant
Yeah.
acceleration.
That's
Okay.
not what I was telling.
So
So
then?
total downward acceleration will be 12.31.
No.
Upward one will be
No. When we say the total resultant acceleration is 2, we are not going to resolve this acceleration part separately. That means for forces, we are not going to apply it separately. Why? We can't, because it is the same object. Okay, we can't think like this total downward acceleration as this 2 plus 9.8. Did you think like that?
no,
Uh-huh.
not like that. I don't know how to explain.
That means when we apply this equation, F equals ma, at once you can get this answer. I don't know what you are describing. Can you send a photo of your work to me? Then I can decide where you have mistakenly understand. Okay, can you WhatsApp me your photo? I will look where you have gone. What about the others? Do you also get the different answers, or is that answer is okay?
So the third one, P equals 18 plus 4 times 9.8.
Yeah, that was the answer you got.
You had to minus 8. You put plus 8.
Yeah. Thanks for that notification. I take it to this side as +8, no? So this should be 2. So then I think it will be the same, no? So this is how much? 4 times 9.8 plus 2. 41.2.
I sent it.
Okay. Now you got this answer. Okay, I will look for your method
Yes,
also.
I got 41.2.
Okay, I will look at that method also. Now others try to work on the question number 6. Okay, Dinesh, your method is correct. I can't say it is wrong. Okay, but the point point is you have gone to find some other unknown features also. Okay, that means you have separately found if that is what happens. These forces are separately applied, and then we can proceed in that more method also. But the point is, uh, we have to find something what is unknown and what is not needed in this process. We are just need to find this force. So applying these forces at once is much okay, but your method is also correct. It's not wrong. Okay. I'm not going to discuss Dinesh method because it will confuse for some others. But that method is correct. Okay, so what we have to find here? The mass now. Mg minus 10 and 5. So when we resolve the forces downwards, this is the force, the weight downwards, mass times the gravity. And upward, there is other force of 10 newtons apply working. So that force is upward. And this should be equal to how much? M times A. What is the mass? We don't know. And we know the acceleration. Downward acceleration is 5 meters per square second. 5. So now what can we do? Take m's to one side, no? And other unknowns to the other side. So we can get, when we take m this side, minus 5m should be equal to 10. So we can take m out. G minus 5 equals 10. So m equals 10 divided by G 9.8 minus 5. So you can have 10 divided by 4.8. What is the answer? 2.08. Mass should be equal to 2.08 kilograms. How can we find the answer for the part B? What are the answers you got? It's the again similar thing we have to do. Build up a equation, no? When you resolve the forces upside, vertically upward, we can have 20. That is one force. What is the other force? Downward, there is a force of mg. And what is the mass? We don't know. We can take it as m. And the acceleration upward is 2. So we can write 20 equals how much? M plus, so yeah, mg plus 2m. Can take m out as a common factor. G plus 2 equals 20. So m should be equal to 20 divided by 9.8 plus 2. How much are we having?
1.69.
1.79, no? 1.79 kilograms. Question number 7. In each scenario, the forces acting on the body in each of the scenario, the forces acting on the body cause it to accelerate with a magnitude of A. Find the value of A. 2G 8A. For almost all the question, it's better to draw the diagrams in yourself in your books, okay? Even the diagram is given in the paper book. You write it yourself, then only the data. When you write down the diagram by yourself, what is happening? You mark all the necessary data and the data goes into your mind. So it's good to mark these. Okay, so now we have to find what? The acceleration of this object. How can we write? At once we can apply the F equals ma equation, no? So force equals mass times acceleration. So what is the total acceleration downward? Sorry, total forces? 2g is acting downwards. And this 8 Newton, that is upward. So we have to make it negative. And this is equals mass. How much is mass? 2 times A. So A should be equal to, when we divide both sides by 2, we can take the acceleration as 2 times 9.8 minus 8 divided by 2. 5.8. How much are we gained the acceleration? Downward acceleration will be 5.8 meters per square second. I'm not going to do the part B because it is a similar one. I will go to the question number 8. Go through it quickly. Now let's try to draw a force diagram for this situation. So the object is 3 kilograms. And this has an acceleration of 2 meters per square second. This direction, let's say, suppose this direction, a force of 10 Newton is applied. Are these all the forces? No. They say there is a friction. So in which direction the frictional forces act? Usually in the opposite direction of the force applied. So there is a frictional force acting on this in this direction. Let's write it as F. And how much they are asking? What is the, calculate the value of the frictional force. So this is the force diagram. And now if we apply this, you can apply either side in this direction, since this acceleration is acting this direction. But if you apply this direction, you have to denote this acceleration with a minus sign. Since I need to find F, I'm marking the forces in this direction. So what are the forces acting? F, the frictional force, minus 10, because 10 acts the other way, should be equal to how much? 3 times, what is our equation again? F equals ma. Total resultant force is this frictional force minus 10. What is the mass? 3. And the acceleration in this direction it is 2, but if it is in the other way, it is minus 2. So F should be equal to how much? 10 plus, sorry, this becomes minus 6. So what is the direct, how much? It's going to be 4 Newton. The frictional, total frictional force will be 4 Newtons. Viranga, is that correct?
Yes.
Okay. If you get different answers or different methods, just ask for the verification. Okay. Question number 9. Let's look at it. Question number is a little bit interesting. Okay. Try to understand it. So what is the data given? They have given us the weight of the lift and the people inside. What else? They say it starts from rest and it gets the speed of 3 meters per second when it travels 5 meters. And what is the part A? They are asking the acceleration. So if you are just going to apply this F equals ma, what is happening? We don't know is this moving upward or downward, no? And there may be some other forces acting. But before that, we can use a motion equation to find the acceleration. It doesn't matter because depending on the other data given, we can find the acceleration. How much? It is in the same hint, it is given also. Use how much? V squared equals u squared plus 2as. They say the lift starts from rest. That means what is the initial acceleration? U should be equal to 0. So V is 3. So 3 to the power 2 should be equal to 0 to the power 2 plus 2 times A. Acceleration we have to find, and the distance travel, how much? 5. How much? So now A should be equal to 9 divided by 10. No? How much are we getting? 0.9 meters per square second. This will be the acceleration. It doesn't matter whether this is traveling upward or downwards. If it can has this achievements within 5 meters, if it can get up to a speed of 3 meters per second, that means it has an acceleration of this much. And what else they are saying? There is a cable attached to this, no? That means there is a tension going on this one. So this is vertically hanging upward, and the total weight, how much is the total weight here? 300 plus 500, it is 800 times G, the total weight of the object. The tension in the cable if the lift is moving vertically downward. Okay, let's calculate what will be the tension when it is moving downwards. Let's see this acceleration. How much of this acceleration? Now we have found 0.9, no? 0.9 meters per square second. So when we put the motion equation, F equals ma downwards, what are the forces acting? 800 G. 800 G, and T, that is working upwards. So minus T equals, what is the mass? 800 times 0.9. So how can we take T? When we take T to the other side and make it the subject, T should be equal to 800 becomes common times G minus 0.9. How much you are getting for T tension? 9.8 minus 0.9. 7,120. This is if what? If the lift is moving downwards. What is happening if this is working up, going upward? So this acceleration will only change. It will have this upward direction, direction of the acceleration. These same symbols. I use T2 here now. So part D. So when we apply this motion equation upward, how much? T2 minus 800 G. These forces are not, this force is not, the weight is not changing, only the tension will change. And mass is also not changing. And the acceleration, that is working upward if this lift is going upward. So 0.9 upwards. How much T2? T2 equals 800 times 9.8 plus 0.9. How much now? What? 8,560. In which occasion does this has a higher tension? A lift has upward or downward? When it is going upward, no? Because it has to give much power to go against the gravity. So if you are in a lift, and in which occasion does it has a higher probability to break those what you call those cables? When it is traveling upward, it has the highest probability to break the lift. Okay. Good. Now try to work out the question number 10. Hope this one is okay with you. Chiranga, is it okay?
Yes, sir.
Okay, when you when you are reading these questions, drawing a little diagram and marking the data is very essential. Then only we can go forward. If you miss one of these data, what is going to happen? Somewhere you are going to stuck. Okay. So they are asking what first they are asking the acceleration, then they are asking the tension of the rope. So this is a 50 kilogram trolley which is attached to a, they say, rope, no? So there is a tension working on this, and they say it is starting from rest. So when you see it is starting from rest, what does that means? The initial acceleration is 0. So you can mark u equals 0. And now what can we do? If we are going to apply motion equations, how many unknowns are there going to be? Tension we don't know, acceleration we don't know. So we get a one equation with two unknowns. It's not helping, no? So there will be another part that we can find the acceleration. What is it? So they have given us a speed as well. So if you think a bit, what is the equation that we can apply for this one? From our motion equations, we can apply v equals u plus at, no? Why? After 2 seconds, it has this speed, 1 meters per second. Because of this data, I thought of applying this equation. So depending on the data given, we have to think what tool we have to use. There are many tools now, no? And depending on the data, only we are using this one because this gives us easily the acceleration. And we know the other terms as well. So how much is v? 1 should be equal to u, starting velocity. It is 0. Acceleration we have to find. Time is also 1. So what is the acceleration? Acceleration equals 1 meters per square second. Why I use this equation? I look at the data given. Then I can say this is the equation that helps me to find the acceleration. If I use v equals v squared equals v squared plus 2s, can we be doing this? No, why? We don't know how much of the distance this has traveled. Okay, now what to do? Now we can apply our second law, Newton's second law equation. No, what is that? F equals ma. When we apply force equals mass times the acceleration, we will apply it on the direction of the tension. So tension, this is the force in this direction, and what is the other vertical force? 20, but it is in the other side. So T minus 20 should be equal to how much? This is equal to mass times the acceleration. Mass is 50 and the acceleration we found 1. So the tension should be equal to how much? 70, no? 70 newtons. There's a tension of 70 newtons. So again, when we are doing these kind of questions, keep in mind we have to decide what tool to use depending on the data given. So marking, noting down each and every data is very important. Okay, if you are stuck in this question, what is the problem? You don't know how to use the data, what tool to use. So in this problem, what are the tools we used? We used two equations. No, one is v equals u plus at, other one is f equals ma. Why I directly use these two? I look at the data given. So by looking at the data, we have to check, or we have to think what tool to use. So it needs again the practice. With the practice, you know how to use which tool. It's like you think you are repairing a car. There are so many tools. At the beginning, what happens? You take the different nuts, the screws to take out one screw, different screwdrivers, no? But with the practice, what happens? For this is not, I can use this screw. Exactly, because your experience tells us if you use this screw, it is easy. Like that. So math learning is similar to that. Okay, now this is some different kind of a question. Okay. Think there is a bus. Okay. There is a bus. And there is you. Okay, you. All of you. Each one of you is here. Not together, only one person. Okay. For Dinusha is here. For Sabri is here. Okay, Tinuka is here. And this is a bus. And the bus is at rest. It is in, let's say, it is in neutral position. Okay. Can you push this bus? What do you think? This is an open question, you can answer. Okay. Is it easy? Is it easy to move this bus in this direction? This is a horizontal ground. Okay. Can you push? Can you move the bus by pushing this way? Okay, let's think another one. This is a bike. Okay, this is Sabri's bike. Sabri's good bike. Okay, and here each of you are here. Can you push this bike in this direction? Chiranga, can you?
Yes.
You can move it. You say you can push it horizontally and move the bike. It is possible, no?
Yes.
What about the bus? Can you?
No.
Why? What is your reason?
Not enough force.
You do that means you can't have enough force. Okay.
Yes.
That means there are no other is there any other horizontal force when you apply?
No.
Okay, so what's the point? Sabri, what is your point? Can you move your bike?
Yes.
Okay, you can move your. What about the bus?
No.
Why not? My question is, why can't you push the bus to move?
Too heavy.
Heavy. Okay. Okay, that's a good answer. That means it is bicycle. The vehicle is heavier than the bus, no? Okay. So, but let's say this is let's say 5 tons bicycle is 150 kilograms. Okay. So this is too much heavy. But the point is this force is vertically downwards. This weight is not affecting us in this direction, no? Vertical direction. What about Dinu? Dinu says there is property. I was going to say that I didn't. Okay. It's okay. The doesn't mind. Think we are pushing the bus of the Keble College. Okay. The bike, my bike, and the Keble College bus. Okay. Not his property. Okay. Then now I feel like any other answers apart from the Sabri's answer that he can't move this because this is too heavy. Dinesh, what do you say?
Friction force is too much.
Huh?
The resistance force is too much.
Actually, the resistance forces, there is no.
It's not there, right?
It's not there.
Because you can't push it.
What is the situation?
Then I don't know.
Huh?
Then I don't know.
I don't know.
Yeah.
Guess. Actually, if you tried, it's a bit hard. It's mostly think it is when it is not moving so fast, the resistance forces are really low. Okay. If it has some sort of speed, then the air resistance will affect us. But since it is at rest, there will be no air resistance, and the friction in the road, it will be also very less. Why? There are tires. These are rotating. Because of that, it's the resistive forces. We can say we can apply a force more than the resistive forces. But what is the problem? Why it is hard to move a bus rather than a bicycle? The point is the inertia. What is the word? Inertia. Have you heard that word earlier? Okay. If you have not heard, don't worry, we will discuss in the future. Usually, object tries to keep its inertia, its state. Okay. If it is moving, it tries to keep its moving position. If it is in rest, it tries to keep in the resting position. So this inertia has an effect with the mass. That is the way point. Okay, when the mass is higher, the inertia is much higher. Okay, when the mass increases, the inertia of the object is increasing. That means it is trying to keep up its state. So when we are trying to change the inertia, there we have to struggle. That's why it is hard. Okay, we will discuss about this point. But if you think in the terms of weight, the activity it has to do the weight is nothing. Okay, that means it's not because of the weight. There is a relationship with the mass. Okay. Okay, so I am just telling you some facts to consider. Think. Okay, again think. These are very interesting facts. Think in your mind when you are free. Why is that? Why did sir tell that? Can't I argue that beyond him saying that like that? Okay, I need that kind of conversation going on with you. Okay, then you will learn many things. Okay, Viranga got a good point. Okay, broken down and can't move. It's okay. That means engine is broken, but you can. I said it is in neutral position, so you should be able to push. If it is a flat tire, then it will be hard. The friction will be much higher. Okay, so we have got time is up, and tomorrow we will be moving to, we will be doing pure mathematics. So from here onwards, we will be doing what? Tuesday we will be doing mechanics, and Thursday we will be doing pure maths, and Wednesday most probably it will be mechanics, but it will change due to the situation. Okay, so tomorrow when you are coming to the school, bring pure maths books. Okay, thank you very much for your support. Let's meet tomorrow. There will be some interesting concept to discuss, and I hope we can go for the third law of Newton. No, we are doing pure maths. Okay. Okay, later we'll discuss. So we'll do things on pure maths. Thank you.
Thank you.
Okay, thank you, sir. Have a
Thank
good
you,
day.
sir.
Thank you, sir.